we are going to learn the most promising source of energy today, and that's the nuclear energy. Now the question is, so what is nuclear energy? So it's the energy that can be harnessed from the nucleus of an atom. Now the thing is, what are the ways by which this energy can be harnessed? And they are, the first one is nuclear fission reaction, the second is nuclear fusion reaction. Now, so what is nuclear fission reaction? So it is basically the splitting up of heavy nucleus into lighter one. But whereas the nuclear fission reaction, it is basically the combination of the lighter nuclei to form a heavy nucleus. Now let's understand nuclear fission reaction in details. For that, what we do? We take an isotope of what? Of uranium-235, and we allow it to collide with neutron. Now what happens? It releases two elements and three neutrons. Let's see it. As neutron collides with 235, it forms barium as one element, krypton as second element, and it liberates three neutrons. Now if we see further, what we notice is there is heat energy. Now the question is, why heat energy is released? The answer is quite simple. If you compare the mass number of the lighter elements like barium and krypton and uranium-235, you will find that there is a difference in mass, and this difference in mass number gets converted into heat energy. Now as we move ahead further, these neutrons further collide with uranium-235 to form once again barium, krypton and three neutrons, and again the heat energy is released. And when we move ahead further, we will find that technically in each step there are two neutrons, which is excess. Now the question is, what happens if there is a liberation of excess neutrons? So the thing is, the reaction goes beyond control, and we call such reaction as uncontrolled chain reaction. So this is the problem. Now so what is the solution? The solution is, we need an element which is going to absorb these excess neutrons, and they are the cadmium rods. And as we see, these excess neutrons is being absorbed, and now the reaction is under control, and such reaction is said to be the controlled chain reaction. So this is the way the nuclear fission reaction takes place in a nuclear reactor. Now let's understand how it actually takes place. For that, let's take a look at the inner section of a nuclear power plant. This is how it exactly looks like. Now let's understand how the heat energy released during the nuclear fission reaction is being used to generate electricity. So let's understand the working of nuclear power plant. So to understand this, let's go through the construction. So the first, as we see, is control rods. What they do, they absorb excess neutrons. Next is what we have is containment building. This is where the nuclear power plant has been established. Next is the moderator. What it does, it slows the neutrons. Next we have uranium fuel rods, and further we have steel reactor vessel. As we have discussed earlier, so during the reaction, neutron collides with uranium-235 and the heat energy is released. So now this nuclear fission leads to liberation of heat energy, and this heat energy goes to a section, what we call it is heat exchanger. Now here the water gains heat energy and gets converted into steam, and this steam has kinetic energy. Now this kinetic energy of steam is being used to rotate turbines, and so the transformation of energy that takes place in this case is the kinetic energy to the mechanical energy. And if you see it further, the turbine is coupled to generator, and the function of generator is to generate electricity. And the transformation of energy that takes place in case of generator is the mechanical energy into electrical energy. So this is how the electricity is generated, and you can see the generator are being further connected to transmission cables where the electrical power is being transmitted for the domestic and industrial applications. Now this steam that is being used to rotate the blades of turbine, it goes to a device, what we call it as condenser. Now here what actually happens is steam gets converted in water while passing through the condenser. Now the same water is being pumped back into heat exchanger, and once again the water is being recycled. So this is how actually the heat liberated in nuclear fission reaction is being used to generate electricity in nuclear power plant. Now moving to the next segment is the materials and their function. The first one, as we see, is heavy water. Now let's understand. The molecular formula of water is H2O, but technically when protium is being replaced with deuterium having greater mass number, this water is said to be heavy water. So moving to the next material is graphite. This is how it looks like, and they actually acts as the moderator, and its function is to control the rate of liberation of neutrons. Moving to the next material is cadmium rods, which we have already discussed it earlier. This is how exactly it looks like, and its function is to absorb excess neutrons, which allow the reaction to happen in a controlled way. So this is how it works. Now talking about the limitations. Before we go further, answer me some simple questions, students. Now, storage of nuclear fuel and the disposal of the nuclear waste, is it a simple task? Answer is no. So what should be the first point? The first point is improper storage and disposal of spent or unused fuel results in environmental contamination. Moving to the second one, the installation cost is high. Moving to the next segment is limited availability of uranium makes large uses of nuclear energy prohibitive. Here prohibitive stands for expensive. So this is how the nuclear energy is being used to generate electricity, and these are the limitations. Moving to the important segment, what we all call is the exam expert corner. And for this module, the important question that is coming right now on screen is, how does a nuclear fusion reaction differ from a nuclear fission reaction? This is the first question. Moving to the next one is, give advantages and disadvantages of harnessing nuclear energy. As we have already discussed these points, it's going to be easy for you all students. Thank you.